Yes, students, today we will discuss fundamentals of fiber optics or optical fibers. So first of all, we have to know that what is the optical fiber. So as you know, an optical fiber is hair thin cylindrical fiber of glass or any transparent medium. Its function is to guide visible and infrared light over a long distance. So this is the structure of optical fiber. It consists of 5 parts. Central part is called core. Second one is cladding. Third one is coating. Fourth, strength member, which provides strength. And fifth is outer jacket, which protect the fiber. So basically, the light signal travel through this core. Now what is core? Core is the central tube of very thin size which is made up of optically transparent medium and which carries the light from transmitter to receiver. The core diameter can vary from 5 micrometer to 100 micrometer. So it is made up of glass. And second, cladding. So what is cladding? Cladding is nothing. It is second part or outer optical material surrounding the core, which covers the core. The main property of cladding is that its reflecting index is lower than that of core. It helps to keep the light within the core, that is, it is responsible for total internal reflection. So it is made up of quartz. Quartz means having refractive index less than glass. Next, buffer coating means upper 3 layers. So it is the plastic coating that protect the fiber made up of silicon rubber, and the typical diameter of fiber after coating is 250 to 300 micrometer. Now this is the working principle. So this optical fiber is based on the principle of total internal reflection. So as you know, this is a phenomenon. It is happened when light travels from denser medium to rarer medium and the angle of incidence is greater than angle of critical angle. So the ray reflect back into the same medium, and this phenomenon is called total internal reflection or TIR. So this is the principle of the optical fiber. And in the optical fiber, the ray undergoes repeated total number of reflections again and again, even if the fiber is bent. So it can travel through the fiber, whatever the shape of the fiber is. Now what is critical angle? So as you know, in the lower classes you have studied, it is the minimum angle of incidence at which the angle of refraction is 90 degree or greater. So you can observe or see there that this is the critical angle C. So it is the angle of incidence and this is the angle of refraction. So it may be 90 or more than 90. So for glass, this angle is 42 degree. And what is acceptance angle? So this is the angle of acceptance. So it is the maximum angle in which external light ray may strike the air or glass interface. This is the air glass interface boundary and still propagate down the fiber, and it can enter inside the fiber. Fiber means core, and second layer is cladding. So through this core the light can travel. Now this is a mathematical formula for acceptance angle, that is theta in maximum is equal to sine inverse of n1 square minus n2 square under root. So where theta incident maximum is called acceptance angle. It is measured in degrees, and n1 is the refractive index of glass fiber, that is core, and n2 is the refractive index of quartz, that is cladding. Now this is the second part. When light enters from air to glass, then the light gets refracted at an angle theta. So theta dash is 90 minus theta. You can observe from this diagram. And this is light cone from where light can gather, or it collects the light from this face. So by using Snell's law, n naught sin I is equal to n1 sin theta. So when light travels from core to cladding, core means having high refractive index, to the cladding means lower refractive index, then it moves from denser to rarer medium. So it may be totally reflected, that is, total internal reflection is there. So by using this formula, and we will use it using the formula Snell's law, sin theta c dash is equal to n2 upon n1. Now there is maximum value of angle of incidence beyond which it does not propagate, rather it is refracted to the cladding medium. So this maximum value of incidence, let it be Im, is called maximum angle of acceptance, and n naught sin Im is called numerical aperture. So this is a new term, numerical aperture. So what is this Na or numerical aperture? So this is mathematical term. So Na is the square root of n1 square minus n2 square, that is refractive index of core, and n2 means refractive index of cladding. So take a square root and we can find the value of numerical aperture. So what is the physical meaning of this numerical aperture? So this aperture is used to describe the light gathering or light collecting ability of the optical fiber. So in optics, this aperture is a dimensionless number that characterizes the range of angles over which the system can accept or emit the light. This is the diagram for numerical aperture. Now the classification. These optical fibers are classified on the basis of the number of modes and on the basis of on the basis of refractive index. So first of all, on the basis of number of modes, these fibers are of two types, that is single mode and multi-mode. And on the basis of refractive index, so it is refractive, not reflective, step index optical fiber and graded index optical fiber. So first one, that is single mode fiber. In single mode fiber, the light travel or propagate through the fiber in a single mode. That is, it has a small core diameter 5 micrometer and high cladding diameter, that is 70 micrometer. So diameter of cladding is more than that of core. So this is single mode fiber. And in multi-mode fiber, this is multi-mode fiber. So it allows a large number of modes for light ray traveling through it. And the core diameter is 40 micrometer and that of cladding is 70. Again, cladding has more diameter as compared to core, but the difference is less. So the relative refractive index difference is also large than single mode. So this is multi-mode and is single mode. On the basis of refractive index, these optical fibers are further classified into two categories, that is step index optical fiber and graded index. So what is step and graded? If you see in the diagram, so this is step index fiber, that is. So in this case, this is the sharp boundary, and in graded index, there is increase, continuous increase, then decrease. There is sharp, it is continuity. And in the single mode, it is single mode. So this is the internal mechanism of step index, graded index and single mode fiber. Now these are differences. In single mode, in step index optical fiber, the refractive index of core and cladding are constant. And the light ray propagates through it in the form of meridianal rays which cross the fiber axis during every reflection at the core cladding boundary. But in graded index, in this type of fiber, it has non-uniform refractive index. Non-uniform, it is not constant. that gradually decreases from the center towards the core cladding interface. So, and the cladding has a uniform refractive index. The light ray propagates through it in the form of helix or helical ray, and they never cross the fiber axis. So this is optical fiber communication system. How the communication is possible in the optical fiber. So this is the basic diagram or block diagram for this system. That is source of information, electrical transmit, and optical source, then optical fiber cable and as transmission medium, then photo detector, then electrical stage, and last it is a destination. So these are the explanation about all components. Now advantages of fiber optics. So these fiber optics have much higher bandwidth, means thousands of channels can be multiplexed together over one strand of fiber. And second one, immunity to noise. Immunity. And third one is safety. Fourth one is high security and less loss, reliability, size, and flexibility. So there are some disadvantages also. The system installation is very costly. Optical fiber technology is very costly. Only point-to-point communication is possible in this case. And precise and costly instruments would be required. And splicing is time consuming and it accepts only unipolar codes. So this is the comparison between optical fiber and normal copper communication. So these are comparison. If we see the distance, it can travel up to 12 miles, but it travel 300 feet. The weight is less as compared to copper, and consumption, it consumes low power, that is 2 watt per user. It consumes more power, it is more than 10 watt per user. And there are other differences also. So these are applications. So optical fibers have wider range of applications. That is, in almost in all fields, it is used in telecommunication, in civil, consumer, industries, military, broadband, and decorations, and in medical sciences. Endoscopy is the main application of optical fiber. So this is the tube having 2 stents. One is used for patient and another is used which sends the message back to the doctor. So this is one for light to illuminate the inside of the patient, another for the camera to send the image back to the doctor. And conclusion, at the last, there are some negative points of optical fibers, but it is an unavoidable fact that optical fiber has revolutionized the field of communication. As soon as the computers will be capable of processing optical signals, the total arena of communication will be opticalized immediately. So this is all about optical fibers. Thank you very much.